All right, now we're going to get to 7.6, which is solving quadratic trigonometric equations. You're going to notice now, just like when we're solving linear equations, linear polynomial equations, and we go to quadratic polynomial equations, the difference is we're going to take the quadratics and turn them into linear, simplify them, factor them down so that we can work with linear equations. I'm going to simplify this a little bit before we get into the trig equations. I'm going to look at a linear equations. X plus 1 is equal to 2. X minus 4 is, x plus 1 is equal to 0 and x minus 4 is equal to 0. These are very straightforward to solve. X is equal to -1 and x is equal to 4. This is how you would solve a linear equation. Once we take one step forward and we get to quadratics, what we actually have is x squared minus 3x minus 4 equal to 0. Now we have a quadratic equation that we need to solve. Our process is to get this into factored form and equal to 0. So to factor, we find two numbers that multiply to be -4 and add up to be -3. We know those are -4 and +1. So we'll turn it into x minus 4, x plus 1 is equal to 0. And then our next step is to set each of these equal to 0 on their own. Set x minus 4 equal to 0 and set x plus 1 equal to 0. So we do x minus 4 equal to 0 and we do x plus 1 equal to 0. And the whole purpose of this process is to take the quadratic and simplify it down to doing purely linear equations. This is exactly what we're going to try to do when we're solving quadratic trig equations. We spent some time looking at linear trig equations from 7.5. Our process for 7.6 now is exactly the same with some few steps in the beginning, which is we're going to try to turn each of these into linear trig equations and then solve them in the exact same way. So this will be a quicker lesson. We're just reviewing factoring for the most part. So let's start with 1a. Sine squared x minus sine x is equal to 2. We need to solve for x between 0 and 2 pi. So obviously the first step when you're dealing with quadratics is to get everything onto one side in factored form equal to 0. So this is what we got. Sine squared x minus sine x minus 2 is equal to 0. For a lot of people, this is difficult to factor. Just because it's something you've never seen before. You've never had to deal with factoring sine and sine. So two numbers that multiply to be sine squared, add up to be -2, or sorry, multiply to be -2 and add up to be sine. It gets a little bit confusing. So if you like, one thing to do is to take the middle term, the sine x, and turn it into a. So if sine x is a, then sine squared would be a squared. So a squared minus a minus 2 is equal to 0. This is much more familiar to us. And now we're going to look for two terms that multiply to be -2 and add up to be -1. And those are going to be what we got. A minus 2 and a plus 1 is equal to 0. So we know a minus 2 is equal to 0 and a plus 1 is equal to 0. But we know a is sine x minus 2 is equal to 0 and sine x plus 1 is equal to 0. Let's start the isolation process. Let's take -2 to the other side. Sine x is equal to 2. And now we have sine x is equal to -1. I'm going to solve this one first because I already know that -1 is an important point. It's one of those special points. -1 is the minimum in a sine function. So it only happens once. It's not going to happen inside a quadrant. I already know -1. The minimum happens at 3 pi over 2, which is the edge of quadrant 3 and quadrant 4. So this one is straightforward. It's going to be 3 pi over 2. This is the one that's a little bit trickier. Sine x is equal to 2. Okay, I'm going to pause 10 seconds, give you a chance to think about what is the problem here. Sine x is equal to 2. I'll tell you that it has no solution. Think about why. We just said that sine x at -1, that's the minimum. The maximum is +1. So this is sine x. This is 1. This is -1. There's 2. this has no solution because it'll never reach 2. So we can ignore sine x equals 2 completely in our solution, and we know the only solution to this between 0 and 2 pi is 3 pi over 2. And we're done with that question. Let's get to the second one. Again, for those of you who are not comfortable with going straight into factoring right away using sine and sine squared, we're going to go ahead and start with sine x is a. So this becomes 3a. So that means sine squared would have to be a squared, and 2 sine squared would be 2a squared, minus 3a plus 1 equals 0. So now we have to find two numbers that multiply. So they have a product of 2 times 1 and a sum of negative 3. So two numbers that multiply to be positive 2 and add up to be negative 3 are going to be negative 2 and negative 1. So what do? We do 2a squared plus 1, that stays the same. The plus 1 and 2a stays the same. But the minus 3a, we're going to turn that into negative 2a minus a. Negative 2a, negative 1a. And now we go through our factoring process, putting imaginary brackets around the first two and on the second two, the third and the fourth, whatever we can, and we factor them. What can we factor from these two? It's 2a, and we're left with a minus 1. What can we factor from negative a and positive 1? Just the negative 1. And we're left with a minus 1. We know we're on the right path because we have a minus 1 and a minus 1. It is the same bracket, same expression in each of these two expressions. So I can factor out a minus 1. So once I factor out a minus 1 divided by a minus 1, that will just be 1. So then inside the bracket, I'm left with 2a. And then a minus 1 divided by a minus 1 will also be 1. So I'm left with a minus 1. A minus 1, 2a minus 1 is equal to 0, which becomes now, so a minus 1 equals 0, but I'm going to write, instead of a, I will write sine x minus 1 is equal to 0, and 2 sine x minus 1 is equal to 0. So I will have sine x is equal to 1, and sine x is equal to a half. I'm running out of space a little bit, so let's move back over to this side. So we're going to have sine x is equal to 1, and sine x is equal to a half. Now again, remember we're looking at from 0 to 2 pi. Sine x will equal to 1 only once because that's the maximum. Sine x will equal to a half twice because it's not the maximum, it's not the middle, and it's not the minimum. So first let's look at what happens here. The maximum for the sine function happens at pi over 2. So I already know my answer here will be pi over 2, and there is only one answer. Sine x is equal to 1 over 2. Same process. Sine x is positive in quadrant 1 and quadrant 2, so I know I'm going to have two angles. Quadrant 1, quadrant 2. So what do? We're going to do sine inverse of a half. So x will equal to, the first part will be pi over 6. Right? We know that the related acute angle is pi over 6. To find it in each of these quadrants, then it becomes simple. Quadrant 1 is pi over 6. Quadrant 2 will be pi minus pi over 6, which means it'll be 5 pi over 6. And we have our 1, 2, 3 solutions. If you'll notice, they're all going to be like this. They're all going to be straightforward in that you take the quadratic and you do have to practice how do you bring it down? How do you factor it? And what I would recommend until you get comfortable is don't hesitate to take the sine, turn the trig into a variable. You can turn it into a, into x, whatever it is you're comfortable with, and use that factoring process to simplify your equation until it becomes a linear equation. Once it's become linear, you treat each part like its own question. Sine x equals to a half, treat it like its own question from 7.5. Sine x equals to 1, treat it like its own question from 7.5. Which is, go through the process. Figure out which quadrant was your answer, is your answer in, how many different times does it occur. There are some questions, they may have a total of maybe 6 answers just because of how it's set up. Okay, so good, again, practice is going to be necessary. Inshallah, you guys will do well.